All right, shh, notes out. We're gonna go. I'm gonna go. All right, I need you to put your physics away if you are studying physics. I'll just go over really fast. If you really think physics is really important, then I will go over all the things really fast, and you can do your physics. But if you don't understand something, don't blame me. Okay. So what we're gonna do is very easy. Just talk about derivative of e to the x, but I'm also gonna talk about derivative of special functions. So today, just talk about d to the dx of e to the x. Well, we already know that's e to the x. That's great. D to the dx of e to the u is equal to eu du dx. Now, a lot of times people ignore that du dx. That's the problem. So right now, I want you to practice two questions. I want you to practice e to the 3x over e to the x plus 1. So I want you to take a derivative of this. Also, I want you to take a derivative of this. E to the 3x, sorry, e to the x minus e to the negative x minus e to the negative 3x over e to the x. Okay, I want you to take a derivative of those two functions, and that way we can finish this part. We're gonna move on to the next part. So Aiden, if I have d to the dx of e to the let's say it's negative 2x, this part is u, and when you do derivative of this part, it's going to be e to the negative 2x times negative 2, like this. So basically, you have to take a derivative of the chain rule within the top. Is it already finished or no? It's good or no? Okay, so I'm gonna go through it. This one is gonna be low D high, so this is a low D high, but this is e to the 3x times 3 minus high D low, which is e to the x over e to the x plus 1 squared. So this means 3e to the 4x. Does that make sense? Because e to the 3x times e to the x e to the 4x plus 3e to the 3x minus e to the 4x over e to the x plus 1 squared. If I want to simplify that, that becomes 2e to the 3x, no, 4x, I lied, plus 3e to the 3x over e to the x plus 1. I can factor out e to the 3x outside, so that's going to be 2e to the x plus 3, I think, over e to the x plus 1 to the second power. And this is my final answer. Low D high, high D low, over low low. If I want to simplify, I combine like term. All the e to the 4x will combine together. And you can factor out the thing. Is this okay or no? Okay, so for this one, you do not need to take derivative at this moment. You should split them to each individual term. And you did that, right? You do not need to do quotient rule. So this is 1 minus e to the negative 2x minus e to the negative 4x. Is that okay? Now I'm going to take a derivative of this because the same function as before. Derivative 1 is 0. Derivative of this, you have to be careful. It'll be negative times negative 2 e to the negative 2x. Negative times negative 4 e to the negative 4x. So it'll be positive e to the negative 2x plus 4e to the negative 4x. Is this okay? Oh. Is this okay?
I'm not thinking that physics does
Is this okay or no? Okay, so I'm gonna give you this question. I can say, hey, find extrema and inflection points. How many guys not finished yet? Not? Okay. This is what I got for the extremer. -1, negative e to the -1 is your relative minimum. And I'm going to take a second derivative. So e to the x, I take a derivative of that. And then plus e to the x times 1. So it'll be e to the x plus x e to the x plus e to the x. It's going to be 2e to the x plus x e to the x. Factor out e to the x. Okay, is this okay for everybody? So you can do second derivative, you can do equation tangent line because you know how to take a derivative. Yeah, that's a much on derivative. We're gonna talk about integration then. Integration of e to the x dx is equal to e to the x plus c. Now integration of e to the u du, be careful with this one. It looks like e to the u plus c, but slightly different. So what is integration of e to the -2x? And just like this, what's integration of e to the -2x? McKenna, what'd you say? Say that again. I'm sorry, my brain is not registering. Say that again. Just.
Would it be negative e over 2 to the -2x?
That's what she said. Okay. All right. Yeah, that's good. So, a lot of people think it's e to the -2x. Anybody think it's e to the -2x? Good. Then you guys are on a better track than when I was a student. So this is 2x du equal to -2 dx, du over -2 equal to dx. So it'll be e to the u and du over -2. So it'd be -1/2 e to the -2x plus c. Good job. Okay, so that now we're gonna give you a little bit more harder one. So what will be e to the 1 over x and then x squared dx. And what's integration of e to the x over 1, actually e to the 2x, e to the 2x between ln of 4 over ln of 2 dx. So those two questions are a little bit more difficult. They're a little bit different than each other, so you gotta be careful. I can ask you average value still. Just 1 over b minus a. Is the physics test next period?
Yes.
Well, I don't know why you guys care about it if you guys don't care about it. You know what I'm saying? You know what I'm trying to say though?
Like a weird between your classes. Is it natural log of 4 and natural log of 2?
Yeah. No, I mean like everybody would get A in that class.
Yeah. Physics? Yeah. I also want to brag to my friends. There's another motivation.
That's a good motivation.
That 100% is a good motivation.
Motivation to be good.
If my motivation is being better than you, that's good.
But it's still negative.
You know what I'm saying though? You could just take a class, get an A, and that's it. Why would you worry about a physics AP exam? Because I would probably take it in college again anyway. Yeah, but the point is that you didn't learn anything throughout. The point is that I will probably take it again in college. If I'm engineer, I'll probably take it over again in college anyway. No, you can skip Cal 2.
I'm doing it for the
You don't want to skip Cal 2? No, most of the school let you, unless you are in Ivy. Not Ivies. But no, they let you if you pass a placement exam. I would just take it in college though. I don't know, ask me.
Wait, I don't. Okay, so you.
Why don't you just
Well,
focus?
which one? What's so random? What is it?
Make sure you change your boundaries.
Yeah.
You?
For you, you could do, yeah.
Well, you posted it to me. I think guys, did you find natural log of 2?
You already got it?
No, stop. I have to get it. You got that.
How do you write this way when you flip your
Yeah, okay. I got 17. I don't know how to find it. Because you can take that 2 and put it through the. You make it.
Not coming back.
So you have e to the ln of 4. Which just becomes. What happened to the 2? No, sure, that's me. I brought 2
Why are we coming back to the X bound?
That's the one right there.
Also, there's something else.
If it's E to the ln, that's fine.
One over you.
So it becomes ln 4 squared.
But then you have to make it bound. Yeah.
Where? Would love to go to Stanford.
Yeah, I think
Is that gonna happen?
You said 1 plus 16. I knew it. Wait.
You got 1/2 Ellen.
Do not convert back to
No, I'm not.
I'm doing another.
Do not convert back to X.
I'm doing another.
Okay.
Why are you gonna do another substitution?
Yeah, I have one. You did it more backwards.
Don't convert back to
You both right now. You should
do better if you do easy out. We're gonna do everything. You do it. If you don't, then your work is gonna be massive. It's gonna be
I know.
All right, so I see a lot of people convert back to X. Guys, I need you to not convert back to X. Just do it in terms of U. You're gonna find your life a lot easier when you go to BC stuff, especially with a trig integral. Please do not go back to X. Joshua, please do not go back to X. U equal to 1 over X, du equal to X to the -1, so -1 X to the -2 dx, and then this is going to be du negative X squared equal to dx, so it'll be e to the u over X squared times negative X squared dx. So this cancel out. That's going to be integration of e to the u du negative, so it'll be negative e to the 1 over X plus c. You got it?
Yeah, I got that one.
Okay, so for this one, you cannot do u equal to 2x. Anybody try to do u equal to 2x? That's not going to work because du is 2, and that doesn't make the problem easier. Actually, u is going to be this part, and I'm going to say this again. I'm going to start taking points off if you convert back to x. Just do it in u. Because your trig substitution is going to be way worse than this. It's going to be 1 page long, half page long. It's going to be a lot of work. So you got to make sure to build a concise habit, an easy habit to do something. So I'm going to say it again, but you're not going to pay attention to me, but I'm going to take points off. E to the 2x, 2e to the x dx, and then du over 2e to the 2x dx. So that's going to be integration of u, this is e to the 2x, and this du over 2e to the 2x. Now cancel out. This is a 1/2 du over u. Please do not convert back to x. I'm going to say this again. Don't blame me for taking points off. I'm going to tell you right now, don't convert back to x. A lot of you guys convert back to x. Don't need to do that. Okay, so I'm going to change the boundary here. So it'll be 1 plus e to the 2 ln of 4. Now be careful because e and ln cannot cancel out directly. So I'm going to rewrite that to 1 plus e to the ln of 4 squared. So 4 squared is 16. Now e and ln cancel out. That's equal to 17. Same thing as the other side. So it'll be 1 plus e to the 2 ln 2. And that's equal to 1 plus e to ln 4, and that's going to be 5. So that'll be 17 over 5. So it'll be 1/2 ln of 17 divided by 5. And that's the final answer. Because subtracting It's negative subtracting. Any questions? Okay, so I'm gonna talk about next thing. I'm gonna go back to talk about derivative of a certain thing. So there's a special functions right now. We're gonna talk about special functions. And before we talk about special function, I want to talk about logarithm of b of m equal to natural log of m over natural log of b. This is in algebra 2 is known as changing base formula. You can change the log base into the natural log base. So it's much easier to do problem. So let's just say if we have y equal to 3 to the x squared like this, right? And we say, hey, I want to take a derivative of this. Do you guys know how to take a derivative of this? I don't want you to do it. I want you to tell me before you do it. Huh? Nope. What'd you say, Armin? Of course, you can do natural log. Use logarithm differentiations. So if you do logarithm differentiation, this is going to be natural log of y, natural log of 3 to the x squared. Why are we doing that? Because due to the power rule of natural log, so we can put this in the front. So that's going to be natural log of y equal to natural log of 3 times x squared. Now, natural log of 3 is what? It's a constant. So it's called constant multiple rule. So imagine that's a 2. You just take a derivative of the x squared. So now we're going to take a derivative of both sides, d to the dx on both sides. So that's going to be y prime over y, just like what we talked about before. And then now this becomes what? ln 3 times 2x. Is that okay? Now I'll move the y back to the other side. So it'll be ln 3 times 2x times 3 to the x squared. And that's your final answer. A lot of you guys screwed up this part last year. It's actually not as hard as you think. Just do the basic logarithm differentiations. And knowing what is constant. Now there's a formula for this in case you want to know. It's going to be d to the dx of a to the u is equal to ln a to the u, and du dx. If you want to memorize this equation, beyond my guess, then you can just use that equation. But the equation is basically get the same thing from just knowing how to do a little bit algebra, take a derivative, and then you're going to figure out the answer. So this is the formula I won't remember on the test. That's because I don't have memory. I don't even know half of you guys' name. My Alzheimer kicked in, so I don't remember it. All right. Shh. Now let's think about how do I take a derivative of this? Log 3 of square root x squared minus 1. And I want to take a derivative of this. Now here's the thing. I don't need to know the derivative of logarithm. I can just do something else. So what can I do? What did you say? Change base. So it's y equal to ln of x squared minus 1 to the 1/2 power over ln of 3, right? If I bring the 1/2 in the front, because this is the exponent rule, so it's going to be y equal to 1/2 ln of 3 times x ln of x squared minus 1. Now, did I do any calculus? I did not do any calculus at all. Okay, I did not do any calculus at all. What I did is I just changed the natural log change the normal log to the natural log form. Now I choose to take a derivative, but before I take a derivative, I need to realize there is a constant here. So Bennett, can you tell me the constant here? Exactly. Where?
Well, I'm not. I wasn't following to begin with. I don't
Okay,
know.
so that's why I need to get back on track. Because I know you're not following. Do you know what I did? From here to here.
I mean, I saw it, but I don't know why.
I use a changing base formula.
Yeah, I think I vaguely remember that, but I don't really.
I use this formula.
Oh.
And then that, it's just gonna be natural log of x squared minus 1 to the 1/2 over natural log of 3. Now if you pay attention, right? Guess what? What's this? But you have to see that constant. It's kind of hard to see. So can I rewrite as 1 over 2 ln 3 times ln of x squared minus 1? And I'm not taking derivative yet. I just says, hey, let me rewrite that write down this the constant. I haven't taken a derivative yet. So if I take a derivative, I'm not natural log both sides. I'm just using the changing base formula. So y prime is going to be 2 ln 3. Now I'm just going to focus on this is u, so it'll be u prime over u, so it'll be 2x over x squared minus 1. So the 2 cancel out, so the answer is going to be x over ln 3 over x squared minus 1. And guess what? If you're interested how the formula look like, which is I don't ever remember this formula, like I said, I don't know. A to the u is equal to 1 over ln of a times u and then du dx. And you'll find out they're exactly the same. Now for me, I don't memorize the formula because memorizing is stupid. And I don't agree with it. Is this okay? Good? Do not memorize this equation. This is so much more painful. If you just don't have math, then you prefer memorizing this equation?
No.
I don't. But if you want to do it, it doesn't matter. It doesn't bother. You're not gonna memorize on AP exam though. You have so many other AP exam you have to know, and so many other formula you have to memorize. This is another one. Is that okay? Now, you know that d to the dx of a to the x, you know that's natural log of a times a to the x, right? What will be integration of a to the x? What do you think? Or even a to the u? What's the integration of a to the x? No, just have to find a way to get rid of this natural log. So be 1 over ln of a to the x. Because you want to take a derivative at ln of a will cancel out, right? So that's going to be plus c. Yeah, don't forget plus c. Which is your mind. Okay, what's the integration 2 to the x dx?
Yo, wait, where is... You're going too fast.
I'm trying to let you study physics.
Well,
I'm trying to finish so I can study physics.
Not ever the physics. I don't have physics anymore. I have physics. I'd rather actually learn what's going on. What?
wait, how did A
Right on, you take it. How was the test?
how did A to the X equal natural log of A?
But he's also doing this one. Anyone hear that slide and take
Where
a
did this
test
come
in mechanics?
So it's different class.
Yeah, but it's the same unit. It's like
I'm both.
Wait. The one with the natural log of A is raised to the A to the X out.
No, 1 over ln of a times a to the x plus c.
Wait, how did A get into natural log of A?
This is the only one I would want you to remember, but 3 to the x squared times 2x dx like this, then u is equal to that, and then you convert everything in terms of u, then you would do the same thing. Okay, I'm done. Yes.
Wait, how did the X equal natural log of A? We have this.
Huh?
Like the very first one, when you derive a to the x, why does that equal natural log of a times a to the x?
It's the same thing I did before.
Okay, that makes sense. Actually, you might say it. We like how this. But then he's saying integral because since this is the if you were
Test next Thursday.
Yeah, that's fine.
So wait, hold on a second. No, wait. Tomorrow we're gonna grade the test. Monday.
Oh, me too. That's scary.
Nearly 9 p.m.
Test Tuesday.
Wait, so what is there? What's gonna be on
What's on it? Okay, so what is on it? Natural log integration, derivative, right? Derivative and natural log of integration and derivative, and the e to the x and special function like this, 2 to the x or log base of 2 of x. You still have to worry about extremas, inflection point, which is something you know how to do. You still have to worry about implicit derivative that's inherent. And then inverse derivative, which is yesterday's homework. And then lastly will be inverse trig derivative and inverse trig integration. Inverse trig integration, inverse trig derivative.
Is this gonna be in the AP exam?
This, yes.
No, the inverse derivative.
Inverse trig, yes. On BC, actually a lot more.
Haven't learned differential derivatives yet?
We learned that after this. And actually we're gonna learn that, we're gonna learn about Newton's formula.
That was not, Newton was not.
No, that Newton Coulomb law is not on that last year.
But differentials, what?
Differential equation, yes.
That was the whole equation.
Yes. And we're gonna review a little bit about kinematic. Then we're gonna talk about area volume and we're done with cut point.
You just get one.
And no, this year we have shell.
Bro, I do.
Zero.
We have shell and arc length.
That was
Yeah, shell method. Shell method. How to say shell? Shell, like a seashell. Seashell.
so no difference.
Sally, so seashell. Oh, say it again. Sally, so seashell by the sea shore. Okay, you're gonna have to write it down for me. I can't memorize all of it.
Are we gonna learn inverse? Well, not learn. Are we gonna review inverse trig tomorrow, or are we gonna bring our test?
We're gonna try to do the test and derivative of inverse trig. Yeah.
Oh wait, I can't. I'm not. I
By the time we get to Calc 2, we will slow everything down. Because this is stuff I should explain. But if you don't know, then you should review a little bit. Sally, so Sally. By the seashore.
Yeah.
There's also. Yeah, you're not. That one's so funny.
Like, I don't know why.
Yeah, but like.
With the four.
Always put Yeah, you are.
Bro, you gotta run. Yes, bro. He knows how this works. Like, for the only difference.
And all of you.
It's a misconception that Force Manual is always the It's not. Exactly.
Yo,
There's an mates are gonna be and you're mates.
oh, you failed it?
This is like more important than it's like how important request is. 5, 3,
But what do you draw somebody okay, here. When you draw an asymptote, when you draw something like this, this is an asymptote, and this is an asymptote. The line is going to go toward asymptote like this, and I draw that in front yesterday too. And I have another point it's going toward like this. It's not going to go like this way. No. It's gonna go towards asymptote. And that's how it works. Okay, that's wait. Okay, so your graph.
I fixed it.
Okay, did you check on Desmos?
Yes.
You did? Okay, right 5. This one going down. This one is going this. This one going this. 7, did you plug in? 7.
I have a question.
If we plug in, hold on a second.
I plugged in.
Yeah, but if I plug in 7, it's average. Okay, if we plug in 3, yeah, well,
You put F1 twice.
oh, okay. Right. 4. Up 2.
This is the improved one. That one is kind of scuffed. You can't see it, so that's why I changed it. Just redo it into one.
Good. This is good. Good. But every homework need to be like this. Not half-ass. You need to check on Desmos too.
Good morning.
Oh. Yeah, got it.
Honestly, no offense, but I don't think your method would be good for me. I just, I didn't think it, I think like it's.
I wrote Bill, walk through the calculus, and then I could do that.
I'm still
Why don't we just like all sit back? Why don't we just like all sit back? You hold on my dad. Dude, I don't like looking at your dad. Where are you like to sit? It's small.
make a shot. You're all tough.
Oh yeah.
Oh, I think it's just a weird. Well, don't you know you talk to the chick that's like a tiny sweet thing there. I know.
Who didn't know? Look at my.
Tiger.
Like the parabola is just like linear. The parabola is like an absolute value that has to.
CP is no joke, bro.
Like you're.
Yeah,
I know how to do it.
Your homework.
Thank you, Mr. Ye. You made the homework easy.
Well, don't tell him it was easy.
I mean, like, just hard enough for like I learned a lot. Yeah, actually, it was super difficult.
Maybe it was too easy. I got all
Yeah, even not the guy.
Maybe it was too easy.
Like, why you just assume? Like, that's pretty early.
Did you see how they did?
Remember every time that I wanted to talk to you? Okay.
We're gonna use our okay, make first one is and then
Actually,
if you plug it in, did you plug it in?
Or like, I do it.
Yeah, what's 3 minus 1?
You know, like, you have oh, it's actually my part.
According to this Frank, why he knows you. Why they are.
You can. It just the X square could be like this, or could be like this. So So if you zoom in if you look at this problem, it's going to look it could be down here, depends on if you put like this put a button here, and if you put a negative in front of it, it becomes
So, meaning that, I get, but why? Because at any point before that, all are negative, you limit one, not negative.
what?
All the limit of y is negative according to the. So how can they be positive? Why?
Because it goes going down. On the left side, it's going down on the right side.
So this is only the direction you go.
Yeah, direction at the end. What happened? All right, so have a seat. So you should check your answer through Desmos. If when you're doing homework, make sure you check your answer. Type in the Desmos, see what it look like, compare to your graph. You do not cheat from Desmos because it doesn't help you on the test. Now, what you can do is you can look at the Desmos. You can say, oh, compare with it. How far away? Like if you got a negative sign, if a negative sign is gonna flip that thing. And you can even sketch your own asymptote, but asymptote is not going to show on the Desmos. That's what's going to be one of the issue is. But most of the time, you're going to be fun when you actually do things like, okay, let me just plug in to work through it. But if you do your homework without checking your Desmos, it's just as bad as you not doing it at all. So because you practice something wrong and you don't go back to fix it. And Desmos is a way to check your answer to see, if it's right. So when you're doing work, please check your Desmos. That's the only thing I'll ask you to do. Okay, so do I need to go over anything? Okay.
How do you graph the gang sign?
Okay, so tell me which one.
The first one.
Okay, so the first one says